information at first, and then I will go into the questions you sent me, and then you have some time, of course, to yeah, ask some other questions. If you don't understand anything, you can always yeah, raise your hand or something like that. Of course, ask further questions about it. Okay, since I got some general questions to the exam, yeah, I think you all know that should know that the exam will be after the transport processes exam, directly after that. So we will have about 50 minutes between the exams. Because there are some German students who also write the transport part, so they can leave and they don't have to leave when you are still writing. So we have a small break between that, about 10 to 15 minutes. Because I was asked, the grades are according to the credit points, so PSE just counts 1/3 of the whole module, and but you have to pass both exams separately, so you have to get 50% of the points in both of the exams. Okay, then we have changed the exam a little bit. In fact, we have shortened the exam, so you have 60 minutes, but we will have about 6 questions and only 2 tasks. Okay, so you have a little bit more time to think about yeah, what you write. So yeah, you will have a little bit more time for that. Because I was asked the question also, you are only allowed to bring a non-programmable calculator, of course a pen, something like that, pen, and yeah, you can bring your own paper, but there should for notes you have enough should have enough paper for all the calculations, for all the answers, but all of your paper you bring, there shouldn't be anything on it, so you can't bring any formulas with you or some tables or something like that. Even if there are no information on it, yeah, you are not allowed to bring any of this. So, are there any general questions for the exam?
I didn't get the paper part. Like, are we supposed to bring our own paper, or will you be giving?
No, I will give you we will give you the paper for the answers. So when you're writing, I don't just want to have the answers to the task or questions, but if you want to should calculate something, I want to see how you calculate it, and there should be enough space on the paper we give you. Yeah, but you can bring some blank paper if you want to take some notes, or yeah, to try something like that, or try something, and that but you won't give it in the end. So you don't have to bring your own paper.
Okay, thank you.
There should be sufficient. Yeah, Donald.
Hi, I just have a question regarding the pension analysis integration part. Will you provide like the papers that you had for, say, exercise 3 and 4, like those blank sheets?
Yeah, so for the heat integration, for example, if you should calculate do the calculating part, we will give you the tables for that. Yeah, that
Okay,
was the question, right?
Yes, correct.
Or if you should draw something or something like that, we will give give you paper for that to grid or something like that. So yeah, that will be provided.
Okay, thank you.
Welcome. Any other questions? Okay, if there are no general questions to the exam, I will start to discuss the questions you sent me. Since I had a meeting, I will not haven't prepared every answer, but I will. That should be a problem. So start with the first questions regarding exercise 4. So as some of you actually recognized, I haven't at first I uploaded the solution to exercise 3 instead to exercise 4, but that should be now changed, should be now right. That was a mistake by me. Okay, and the first question was, sorry. Yeah, regarding exercise 4.1, and there was a question why we connect in the, what was it? You see, the heat exchanger network, why we did connect above the pinch point, the heat exchanger network above the pinch point, why we did connect the cold stream of low heat capacity with a hot stream of higher heat capacity, because the rule says otherwise. So I can show you. Let's see. It's about, where is it? Where is it? Here you go. So you should see the grid now. Okay, I think it's about this connection here. No, was it this one? Yeah, this connection. And the rule is always that we want to connect higher heat capacity flows which are going away from the pinch point than to the pinch point. But it's only around the pinch point. So the rule of the higher and lower heat capacities that we want to connect is only true at the pinch point. So for example, if you look at this connection here, this heat exchanger with 300 kilowatt, we have a heat capacity flow stream that goes away from the pinch point of 30 kilowatt per Kelvin, and here going to the pinch point is 20. That's what we want. We want a lower heat capacity stream to the pinch point than what's going away. And here we have connected heat flow rate of 20 kilowatt per Kelvin with a heat capacity flow of 12 Kelvin per kilowatt. But this is away from the pinch point, right? So this is the heat exchanger that is at the pinch point regarding the flow to the pinch point. So that the rule is only true for heat exchangers at the pinch point. Okay. Is this clear, or did I get the question wrong maybe?
Yeah.
Is it it's clear? Okay, perfect. Maybe if I did get the question wrong, then you should tell me. Always, I think.
Can I ask a question to the same exercise or to the same task?
Yeah, sure.
So after we optimize the heat exchanger network, from the hot utility and the cold utility, we have 500 kilowatts of new heat coming into the system. Why would it be 500 for the hot utility? I calculated it at 480.
Let's see. So for 4.1 was it?
Yeah. After we optimize the heat exchanger network for the path,
Yeah.
there you can see it says 500 kilowatts from the hot utility to stream C1, I think it is. And I would have thought it would be 480 because we have 380 kilowatts beforehand prior to optimization. And then after we connect above the pinch with below the pinch, we lose the 100 kilowatt stream from stream connection between H2 and C1, meaning we would just need to compensate that or not.
Let me get it. So can you repeat why you think it's 480?
So before we optimized it, we had the 100 kilowatt stream connected between H2 and C1. And if we lose that stream that heats up C1, wouldn't we just need 100 kilowatts more?
But we didn't eliminate this heat exchange actually. We did eliminate this. You think this would be more suitable to eliminate this one, or what is it? Because we have eliminated this heat exchanger here, kind of, or maybe we combined this two. Depends on how you see it, but we don't have this 120 kilowatt we get here, but just this 100 kilowatt.
But then the question I think is still the same. So we would connect then the above the pinch with below the pinch.
Yeah.
And wouldn't that mean that our C1 stream above the pinch is not being cooled sufficiently if we lose the 100 kilowatts and don't change anything on the utility?
But we did change the utility, right? I mean, here we have 380 kilowatt and we have here 500.
Yes, but hypothetically, if we wouldn't change the utility, we would be losing the 100 kilowatts of energy above the pinch.
So if you mean if we would cross out this heat exchanger instead of this one, or what do you mean? I'm not sure if I.
No, we'd still cross out the 120 kilowatts stream because it's the smallest one in the path.
Yeah.
But we're replacing it with the 100 kilowatt stream or not?
We don't really actually what I said was a bit misleading probably, because we don't really replace it, because we just cross it out. And when we think about it, when we are crossing this heat exchanger out, we don't start at here in this heat exchanger on the cold side, not with 360 Kelvin, but with 350 Kelvin, right? Because we didn't heat up the cold stream C1 of anyway, right? So this inlet temperature here is 300 in the first heat exchanger network. We have an inlet temperature of 360 at the pinch point, and we have heated the stream up about 8 Kelvin. And if we don't have this heat exchanger, we have an inlet temperature here of 350 kilowatt. And so we get an outlet temperature here of the cold stream of 358 Kelvin. And so we need to heat up the C1 with the utility stream, and we need exactly 100 kilowatt more here, because that's what we have crossed out earlier. Is this answering your question? I'm not really sure.
You meant 120 more, correct?
Yeah, 120 more, because we crossed it out, right?
Okay.
Because what we don't integrate, we have to add through the utilities.
I see. Thank you.
Right. Is it clear or not?
Yeah, that's
okay.
Clear.
Okay, perfect. Perfect. Okay, any other questions regarding this task?
Oh, yes, I have a question. In the task that is specified, we have two parts, A and B. I think here, I don't really understand what is the difference between. I thought they are the one and the same.
I saw the question. Let's see. Wasn't really had that much time to look into it, but I saw the question sent me. Okay, you mean A and B is nearly is technically the same. Okay. No, it's okay. We have to do A actually to do B. I explain what is meant here. Let's see where it is. Share the screen. Okay, so the first question was draw the grid diagram that is divided. Okay, the grid diagram is just this here, without any heat exchange at all. Okay, this is the grid diagram, so very simple. And the B is constructing the heat exchanger network. So this is the heat exchanger network actually. Without the heat exchangers, it's the grid diagram and the heat exchanger network with the heat exchangers.
Okay, so if we get this in the exam, can we just combine together?
Yeah, in the exam probably it's mentioned that you should probably just construct the heat exchanger network. And I can say if this would be divided in the exam and you would draw the heat exchanger network, you obviously would have solved task A2, and I would give you the full points, even though there isn't a standing task A there. Okay, so if I see that you did it both, there won't be a problem of you losing any points because you don't said it's A and B, but it's just B. Okay.
Okay, one more question here. We have something called targeting step. I did not understand how we got a different area. What is a targeting step?
Okay, the targeting step. Let's see. The targeting step, which what we have done in exercise 3, actually, because as some of you may have recognized, um, task 3 and 4 are exactly the same systems. Yeah, it's the same amount of hot streams and the same temperature. And the targeting step is just an estimation step, kind of. Okay, so in the targeting step, we want to see how much utility or cold utility we need, how much how we just estimate the costs. Okay, and as you may have recognized in the targeting step, we are calculating the investment costs with average heat exchanger areas, right? But if you would have the actual cost, you would have to calculate all the costs for each individual heat exchanger network. You can't take just the average areas of the heat exchangers, but it's a good estimation, and it's much quicker than to really calculate the costs. I mean, if you would build this in the industry, you of course had another step because you have to get to the suppliers and ask them for their prices. But yeah, that it's a small difference, and yeah, in task 4 we are more cost, right? Because yeah, we didn't calculate here the average heat exchanger area. Right, because we calculated each individually. And then we tried to optimize the heat exchanger network because that heat exchanger network with the best energy integration isn't the cheapest always. Does that make it clear, or is it still not clear?
Thank you.
You can ask again if I'm not making this clear to you. We have some time here. Okay. I saw your mail just this morning, so I wasn't couldn't look into it in detail. Do you have any other questions? Then you can maybe ask them now.
I have one question from exercise 3.1.
Okay, then we are going to 3.1. Let's see.
No, actually 3.2. Calculation of audit utility costs.
Okay. Yes. 3.1 was it? Or 3.2?
3.2.
Yeah. What was the question?
Why did we multiply it by 813.4? Shouldn't it be multiplied by 58.1? Because we calculated the cold utility requirement as 58.1 kilowatts.
I have an answer to that. It's just a mistake in the write-up. So if you calculated by that, then it would come to the right answer. If you put in 58.
Oh,
it's just a mistake in the PDF.
Okay, thank you.
Okay, let me see. So I can correct it. So I need some help probably. So where was exactly the problem here?
Not here. 3.2.
Yeah, I'm sorry. 3.2. Okay.
This part. 8.
Okay. I see. Okay, thank you. Yeah, I will correct that and we'll upload it later. You're right that this mistake here in the PDF. Okay. Okay. All right. Okay. Any questions regarding the exercises? So we will just.
One more question I have regarding the pinch point. How do we shift the composite curves? Like if we have multiple streams, suppose 3 streams, how can we do it manually? Because I don't know, I could not. If I have just one single line, we can still shift it. But if we have 2, 3 lines of different slopes, how do we shift it to get the minimum temperature?
Do you talk about combining the composite curves, or do you really talk about the shifting here? So
the shifting, like I could get till here, but then how do we shift it manually to this part?
Okay. What you can do is, let me see if I have it here in the solution. No. Okay. What you can do is you can take, for example, these utility curves and take the cold utility, for example, and draw a composite curve which is shifted 10 Kelvin up. So not 10 Kelvin, the T minimum. Okay, you can shift this cold curve about 10 or at the amount of a T minimal up, and then you can get you would change it as where one point hit each other, right? And then you can take this curve this you had and just put it at 10 kilowatt down, so at the amount of the T minimal. That would be one solution. I'm not sure if that was clear.
Okay.
Not really.
I can try.
So,
I try.
Okay, what you is it clear what I mean, or are you not sure what I mean?
I got it. You are asking me to shift the curves up and then see, right?
Yeah, and then you can get the intersection where they intersect. There you can shift it back down, and then you have the right result. Okay, the most important I can tell you for the most important thing here for the exam is that you know how to do it. Okay, that you know how to do it, because I know it's a bit stressful, especially in an exam, to draw it and to shift these curves, especially if they are not that simple. So that's all of a hint I can give you. Okay.
Okay, thank you.
All right. So yeah, Donald, you have a question too.
Hi. So on exercise 2.1, part C.
2.1. Yeah, let me open it. 2.1C, yes.
So I have the solution with me, but even with the video, you didn't really explain as to why extractive distillation and liquid 2.1, 2.3.
I'm sorry. Yeah. Yeah. 2.1C. Okay. But do you mean the flow sheet, right?
No, 2.1.
2.1. Yeah.
Not 2. Yeah.
Okay, let me see.
You just test it. Yeah.
Let's see. I think document here.
I think that was right.
Yeah. Okay. I'm sorry. Yeah, I didn't saw it. Like, answer was there. Yeah. Okay.
So you have the answer there, but I was trying to figure out maybe what makes each of the processes like distinct. Like why would you choose it, and what would be the reason? And then also, I was looking at the given data, which is just the mass fraction and boiling point. And I know the reason why you choose those three is that because they have close boiling points. But like, if asked in the exam, what other techniques and then why, right?
Yeah. Basically, what I just wanted to know here is that you think of different possibilities to of different separation techniques. So of course you can't say if extractive distillation will work for these components, right? Because you only have the boiling point as information. So that's all I wanted to hear. I wanted to hear some examples here, or that if we would have these in the exam, I just wanted to want you to give some example of different separation techniques which are suitable here for liquids. Or, I mean, you could maybe it's feasible to even use gaseous separation techniques or something like that. Yeah, but that's all basically. So you can't say extractive distillation is very suitable here, but it is a possible alternative until proven otherwise. Okay, so you won't get a system where you have to know which separation techniques works very good. There may be a question where it's given that one separation technique is not suitable, and if then there is a question regarding what other possibilities are there, then you should give possible separation techniques that you know of that don't have a problem with. I think we got did we have here? Yeah, we got C and D, right? Yeah, boiling point really close to each other. So so a separation technique which isn't influenced by the boiling points being so close to each other. That's all I want to hear here.
Yeah, okay. Because I mean, I could see another follow-up question after this, where say you ask which technique is possible and like what parameter or what factors would you have to consider to choose that? Say like for adsorption, like you'd say, if you choose adsorption, what else would you need to know? Like you need to know polarity, that kind of thing.
We
won't
try
to figure out that.
Okay, we won't get into that much of detail. So maybe there's a question where we have an, I don't know, azeotrope or actually a boiling point really close to each other, and then I wanted to hear of maybe there's a question where think of different separation techniques or different techniques what you can do to maybe change this to maybe separate the system, and these separation techniques don't have to be true for the system given, but from the data we give you. So if you just have the information that it's an azeotrope, of course you don't just say okay, then it's given that I don't know, a distillation or is not suitable, but what can you do to maybe make even distillation suitable or anything like that? Okay, but I won't get into much of detail from the thermodynamic standpoint.
Okay, that sounds good. Thank you.
Good. Adele, you got another question regarding this task? Or another?
Yeah, that 3.1 or 3.2 is how to calculate in general the minimum required number of heat exchangers. 3.1 and 3.2.
3.1 and 3.2.
Yeah, exactly. 31. In here, the minimum number of heat exchangers is 5. Based on this equation?
There is an equation given in the lecture, pretty sure. I think it's not given here, right? But it has to do something with the amount of streams you have and utilities and stuff like that. You have to look into the lecture. I'm not exactly sure in which lecture it is, but there is an equation there. Maybe you can think even about what makes sense. But yeah, there is an equation. It's pretty simple. Okay. Any other questions regarding any exercise? No? question regarding the lecture slides. Give me some time to look it up, prepare it. So actually, was maybe a bit misleading here in the lecture. So what we had was, sorry, here there was a bit confusion about the QC min and the QCH, right? Because actually here in this case, the QC min sounds like cold utility, but actually it's the hot utility needed here, right? So Ryan asked me the question. That's of course a bit misleading. I wouldn't have called it that way. I don't know if it was a mistake. I think so. But of course, this is the cold utility needed here, the minimal cold utility needed. Right, that was a question.
I'm so sorry.
Yeah.
You said it's hot utilities and you said cold utility? I couldn't understand.
Okay. We have here the composite curves. This is clear what we have here for a diagram. See that?
Yeah, it's clear.
Yeah. Okay. And then we shifted the curves again, so we have here the minimal temperature difference here, and the difference here between the endpoint of the hot hot composite curve, and between the end of the cold composite curve, that this in the diagram here we have the Q given here in the x-axis, and we can just see that it's the 130 kilowatt of hot utility needed. And the question was, because here we have delta QC min, right? And this sounds like cold utility.
Yeah, it's not. Yeah, it's not.
It's the hot utility needed. That was the question.
Yeah.
Right.
I thought you said it's hot, cold utility again. I'm just confused.
Okay. Maybe I did. Then
I'm sorry. Maybe I referred wrong as well.
Okay. Yeah. I don't know if maybe I said the wrong word again. Okay. I think yeah, I understand it's a bit misleading here with the QC min, but of course it's here this difference is the hot utility we need, right?
Thank you.
Okay. Any other questions regarding the exams or lecture? I think I have answered all the questions I got via mail. If not, let me know. Or now is your time to ask any other questions. But if it's regarding the lecture, I might not be able to answer it right away, maybe. So any questions regarding the exam, lecture, exercises? Okay. Everything clear? Okay, I will write an email again that the exam changed a little, that we have just 2 tasks. So the exam for you is a bit shortened, a little bit more time for your task, actually, because you have less tests, not more time. I think you get it. Yeah, I will write an email again, and yeah, if you have questions, you can write me an email. I will try to answer them by email. It may take maybe a day or something like that, because yeah, I have other tasks to do. But I will try to answer them before next Thursday, of course. Then I will see you next Thursday. And if there are no other questions, bye. Have a nice day, and yeah, already good luck for the exam.
Thank you.
Okay, thank you.
Thank you.
Thank you so much.
Bye.
Bye.